Okay, multiplying a vector by a scalar. So you can actually multiply a vector by a scalar. And it works, similar just to multiplying two numbers. So if you have a vector u and you want to multiply it by 2, you do just what you think you would do. You just make vector u twice as long. So it's like you have 2 of vector u. So it turns out it just looks like that. So you can actually multiply a vector by a scalar. And it can even be negative. So let's say you had vector u again, but this time you wanted to figure out what's negative 3 times vector u. It would be like 3 times as long, and it would go in the opposite direction. I mean, that could be a rough sketch there, but that's essentially what it would look like. So that's scalar. That's what multiplying a vector times a scalar is. And even in algebraic vectors, it's pretty simple. So if you had the vector like 2, 3, and you multiplied it by a scalar, let's say if you multiplied vector 2, 3 by a scalar like 4, it would just give you 8 times 12. Or 8 times 12, 8, 12. So it works the same way. You're just multiplying it. That's scalar, multiplying a vector by a scalar. There's something else, another term that you should know, and it's collinear. To know that term. So collinear vectors, are vectors that they lie on a straight line when arranged like tail to tail or head to tail or whatever. They're scalar multiple. They can be scalar multiples of each other, and they're parallel. So they have to lie, like they lie on the same line as each other. So they're collinear. They lie on the same line. So they're like, they could be like scalar multiples. So if this was like vector u, this whole thing would be like 2 times vector u. Yeah. I don't know what else to say about collinear. It just means they lie on the same line. Like if you're talking algebraic vectors too, points or vector, they're collinear if they lie on the same line, right? So we know that from even like, I don't know. So these 3 points would be collinear because they lie on the same line. So that's what the word collinear means. It's going to come up later, so it's good to just know that. Another thing I wanted to tell you, there's not too much. I kind of already showed you this with like algebraic vectors, but the distributive property holds true for any scalar. So if you have a scalar, usually we use k to represent scalar quantity. If you had k and you're multiplying it by like vector u plus vector v, you can actually distribute the scalar amongst the two vectors. So it would turn out to be k times vector u plus k times vector v. So often we use the letter k to represent a scalar, but it doesn't have to be. And that's the distributive property. So it works just the same as we learned it back in grade 9 or 10. There's also like the associative property, and that just shows that it doesn't really matter what order you do things in. So if you had a scalar a and b, and you're multiplying them by each other, and then you're multiplying it by vector v, so you're multiplying all these 3 things together, you can multiply them in any order. So you could actually multiply the scalar b times vector v, and then multiply it by a. Like it doesn't really matter what order you do things in. And I guess that's it.